Mr. Coleoto here, and in this next chapter, we're going to look at chapter 5. We're going to talk a lot about relationships that are occurring within or inside of the triangle. So here I have a triangle ABC, and I'm going to talk about two concepts, both the midpoint and the midsegment. Midpoint is something you've heard before. Here we have line segment AB, and the midpoint is just the point that divides or bisects this segment into two congruent segments. So BD is congruent to DA. Once we have two or more midpoints, we can find a midsegment. And as you can see in this picture, the midsegment is just a segment that is created by connecting two midpoints. I only have one midsegment drawn, but I could find the midpoint of BC and actually connect segment D to this point here, and then I could connect these up as well. So we could draw all three midsegments of this triangle. This theorem's a little wordy, but it makes a lot of sense. It's the Midsegment Theorem, which tells us that if we have a midsegment, like DE right here, that is connecting the midpoint of AB to the midpoint of BC, so we have DE is parallel to AC, and that's shown here in the picture. The important thing about this is that these two are parallel, and then the third side is twice the length. So in other words, DE is half the length of AC, or AC is twice the length of DE. So these formulas here are what you really need to be aware of, but please don't just memorize formulas. That makes no sense to do. What makes more sense is just, well, looking at the picture. As long as you can remember a 2-to-1 ratio, we can figure this out. So in this first example, we have that DF is a midsegment of triangle ABC. So we should know that DF is half the length of CB. So to solve for x, we would have that 2 times 23 is going to equal the length of CB, which here is noted as x. So 46 must be equal to x. Here we have the midpoints of this triangle. D, E, and F are midpoints of the sides. And interior to this triangle is now a new triangle formed by all of the different mid-segments. A couple questions are asked here. First, well, what can we say based on the fact that, well, all these problems that are given down here? First thing says DE is parallel to. Well, we know that a midsegment is parallel to its other segment, the base here, which is the third segment not connecting the midsegment. So DE is parallel to line segment AC. We can also go down here to number 4. I see that AB must be parallel to its midsegment, FE. So I can write that in now as well. And I'll go down to number 5 since we're working on the parallel ones first. BC is parallel to its midsegment, DF. These should be pretty easy because you can just see them on the picture. No surprise, those lines look parallel. Let's just draw them out. Now, it could get a little more difficult in these next couple ones. It shouldn't, but you have to actually think a little bit on these ones. FE is equal to 5. So here we have FE is 5. I'm just going to go ahead and write that right on the triangle. If FE is 5, we know that AB has to be double that. So AB would be 10, because remember, the midsegment is half the length of the third side, and AB is that third side. AC is 24 in number 3. So if AC, this bottom edge here, I'm going to write that right down on my triangle. We have AC, 24. So DE must be half of that. Half of 24, 24 divided by 2 is equal to 12. And then finally in number 6, if FD is 32, that's a midsegment. So this outside segment should be 2 times that. 2 times 32, which is 64. For this last example, we again have that D, I, and F are all midpoints of the sides. So these lines that are connecting these are then mid-segments. We're given that AB is equal to 4x minus 8. So this side of the larger triangle is 4x minus 8. I'm going to write that down. And IF is equal to x plus 6. X plus 6. That's the mid-segment. They want us to find the length of AB and of AD. So this problem is going to take a couple different steps. First thing we can do is set up our problem. The larger side, 4x minus 8, is 2 times the inner side, so the mid-segment, x plus 6. Now I have to carry out the algebra and just solve for x. I'm going to distribute the 2 to begin with. 2x plus 12 is equal to 4x minus 8. Now put together your like terms. I'm going to add 8 to both sides, as well as subtract 2x from both sides. 2x cancels, 8 cancels, and we're left with 2x is equal to 20, so x must be equal to 10. Now that I know what x is equal, I can go ahead and plug this back in. For the mid-segment, 10 plus 6 is equal to 16, so IF is 16. Now, we weren't really asked to find that. What we were asked to find was AD. But if AD is half of AB, it should be 16, which would also mean DB was 16. Now, if you didn't want to do that, you could just plug in x into the entire segment. 4 times 10 minus 8 is 40 minus 8, or 32. Then once you know the length of AB, which was part of what we needed to find, so this is equal to AB, AD is just half of that, so AD would be half of 32, or 16.